Good afternoon, class. So in this video, what I'd like to do is to use what I did in the last video about electric potential and actually illustrate that using an actual Van de Graaff generator. So here it is. So it's basically a big metal ball, right? It's empty on the inside. We've got a metal rod going down the length of it, and then there's this plastic pipe with a rubber belt in the middle, and that will actually help generate the charges that are going to be present in this Van de Graaff generator. If you may not be able to see it here, but you may be able to see it in class later on. There are a little bit sharper points in here. These sharper points at the top and the bottom are what their purpose is to make sure that you are able to generate a really large charge very quickly. Okay, and then so what you would do is you would start by rotating this wheel like this, get this wheel going, and that will generate a charge on this, on this Van de Graaff generator. I also have this little wand over here to help discharge it anytime. As you can see, this wand is connected by a wire. That wire leads over here to two different ones. There's one that is a little bit more red or pinkish in color, and the other one is black. The black wire is to go to ground, and the redder wire goes into actually discharging, is the part that connects back to this wand that allows the charges to flow from here through the wire all the way back into the ground. And that's why I also put that black wire on the ground so it discharges there safely. So what I'll do to demonstrate this is you put the ball back, ball on top. The reason I do this is to make sure that when I generate the charges, a lot of it will collect on this surface, and that way it'll be easier for me to pick them up. Now, as you can see, I'm not standing on anything, so when I touch this, I'm actually going to, if I touch this myself, I'm actually going to discharge the Van de Graaff generator and bring it back to a lower electrical potential. So let's get this charged up a little bit. We rotate this for a bit, and then possibly you could hear it discharge as I get it going. Maybe we'll try that one more time. It's a little bit hard. I apologize with trying to hold it steady yourself, because that means I'm touching it, and that means the electric potential is building up, but I'm not actually discharging as much of it. So there's a little bit of a discharge there as I move it around. You can also try this. This of course could be dealt. You could also do this and I might do this in class later on with the demonstration. Usually you'd use your hair to kind of to see how well the electric attraction is. But that's what this looks like. So to illustrate from my previous video, if you touch this while this is highly charged and has a high voltage, now I have the high voltage and I'm discharging it into the ground. So if I just touch it, that initial touch is gonna raise my voltage from 0 to whatever the Van de Graaff generator has. That can shock me. Fortunately, because this is a hand-cranked Van de Graaff generator, this can't get to as high a voltage. It wouldn't be a high enough voltage to kill me. So I can get this charged up as much as I want, and then touch it as much as I want, and it won't hurt me. It may shock me a little bit, but it won't. Nothing dangerous. Now, one note of safety for this, just so that everyone is aware, you don't want to touch it with the tip of your finger, because there is a lot of nerve endings in the tip of your finger. Typically, if you're going to discharge something, or if you feel or suspect that you are at a higher voltage or a higher electrical charge compared to the rest of the surroundings, then especially, and the example being, if you were ever on a carpet and you rubbed your feet on the carpet, what you might want to do is, instead of touching the door handle or any metal object with your finger, you might want to touch it instead with the knuckle. Okay, because you can still discharge, but there's a lot less nerve endings in this part of your finger versus the tip of your finger over here. So that way you can kind of stay a little bit more safe. You can discharge yourself as much as you need to without actually getting hurt by that. So this is an illustration of what the Van de Graaff generator looked like in my example from the last video. Good luck in your studies, and may the force be with you.